Greetings everyone. Welcome to my YouTube channel for Kangaroo Maths and Science Academy. Together we strive for a change through education. Ladies and gentlemen, I want to take you through Mathematics Paper 1 Grade 11, which I believe you'll be writing on Friday. Right, without wasting time, let me share the paper. I'll go through the November 2018 question paper. Right, which is out of 150, and it's a 3-hour paper. Right, let's now attend to the question. Right, in terms of the instruction, it says we need to round off to 2 decimal places unless otherwise stated. Yes, I think this is the relevant instruction for now. These other ones are not relevant for me on this paper. All right, this is the first one. We know it's algebra. The first one, it says solve for x in each of the following. By looking at this, we can see that we have x into x plus, I'm saying x into 2x plus 1. Okay, let me just use this one. So x into 2x plus 1 equals to 0. What's going on with me? Okay, just a minute, guys. So it's x into 2x plus 1 equals to 0. So this one is straightforward. We know that if we have an expression that is equated to 0, we can just equate all the expression to 0. So it means this is the same as x equals to 0 or 2x plus 1 equals to 0. Then we can solve for x. We say x equals to 0, or we transpose 1 to the right-hand side, means x would be negative 1 over 2. So this is the answers for the first question. Right, the second one, it says 5x squared plus 2x minus 6 equals to 0. We need to correct to 2 decimal places. Obviously, this is an example of a problem where you need to use a quadratic formula. So we have, first of all, before we use a quadratic formula, let's check if the equation is in the standard form. 5x squared plus 2x minus 6, it's in a standard form. It is in the form of ax squared plus bx plus c, which means we can now use a quadratic formula. So it will be minus b plus or minus the root of b squared minus 4ac, everything divided by 2a. Now let's do the substitution. The b there, remember that we have the a, the b, and the c. So the b, it's positive 2, but still there's a minus here, plus or minus the root of the b, also it's positive 2 squared, minus 4 into the a, it's 5, and the c, it's negative 6. Everything divided by 2 times 5. So if we work this out, this would be negative 2 plus or minus the root of, then we divide this by 10. So when we expand, this would be negative 2 plus the root of the, we need to get that answer by 10, or x, it's negative 2 minus the root, then divide by 10. Let's try to work out this, the values in the root sign. So we'll have 2 squared minus 4 times 5 times negative 6. If you work this out, you will get 124. So this will be 124, and 124. So to get the answer will be negative 2 plus the root of 124 divided by 10. So it means the first value will be 0.91 if you are rounding to 2 decimal places. The negative 2, negative root 124 divided by 10. This will give us the value of, or x will be negative 1.31. So in terms of the marks, I believe it will be the marks for the 124, the answers. Right, then now that is the answer. Right, then moving on to 1.1.3, this is an example of an inequality. And first of all, since that is an equality, we need to ensure that the equation is written in a standard form. And by looking at this, the equation is not in a standard form. And to write that in a standard form, it means we need to transpose the 3x to the left-hand side. And by so doing, it means we'll have the following. So with 1.1.3, we'll have 2x squared minus 3x, yes, then minus 2 is greater or equals to 0. I believe you understand what I've done. This is, when it comes to the sign, to change the sign. But still, when I rearrange it, will be in the form of ax squared plus bx plus c. Then from here, we need to factorize. So let's make factorization. If you factorize, then you're going to have factors of 2x squared. This will be 2x and x. And now we need to get the factors of 2 such that the middle term will be minus 3. And again, ladies and gentlemen, let's look at this sign. This sign is what is one of the most important, because it's telling us that whatever we want to work out there, when we multiply the signs, they must give us negative. Obviously, it means we have to use opposite signs. So to do that means we have to check, okay, fine, we want minus 3. And what are the factors of 2 here? Obviously will be 2 and 1. So if I can put 2 here and here I put 1, then it means this side should be negative and this side should be positive. Let's confirm that. 2x multiplied by x, this will give us 2x squared. 2x multiplied by negative 2, this will give us negative 4x. And positive 1 multiplied by x, this will give us positive x. And lastly, we have negative 2. So let us look at the middle term. So minus 4x plus 1 is minus 3. So it is the correct factor. So which means now that we have correctly factorized. Remember, when we are dealing with inequality, the only way an inequality sign can change is when you divide or you multiply by the negative sign. So if you multiply or you divide by the negative sign, the inequality will change. Right, then which means that here, since we are dealing with inequalities, we can now determine the critical values. So the critical values here, we solve for x, it will be x equals to minus half or x equals to 2. So now in other book, we can also use and instead of or, there's no problem. Then now, in that case, we have, we draw the number line. Let's draw the number line. Which number comes first between minus half and 2? It's obvious it's minus half, followed by the 2. Then right. So in this question, I'm not going to use the approach of a graph. I will use the approach of the sign. So let's do this. Give me any value that is bigger than 3. Any value bigger than 2. Any value that is above 2. It can be 3, it can be 4. So let's do this. Let's say where there is x into that expression. Where there is x, we substitute by, okay, just a minute. Where there is x, let's substitute by 3 to get the sign. And to do so, it means we'll say, okay, fine. Where there is x here, 2 times 3, it's 6. And 6 plus 1, it's a positive number. And the 3 minus 2, it's still a positive number, it's 1. So positive times positive, it's positive. It means if you use any value bigger than 2, it will be positive, which means any value between minus half and 2 will be negative, and this side will be positive. So as a rule of thumb, is this side is positive, you need to confirm, but this one will be negative and the other one will be positive. But now, in terms of our solution, for example, if we choose, let's say we come with any value, let's say we want a number between minus half and 2, and 2, it will be 0. Where there is x here, if you substitute by 0, 2 times 0 would be 0 plus 1 will be positive, and 0 minus 2 will be negative. See that positive times negative will still be negative. That's why we are saying the sign that it's negative. All right, in this case, guys, we want to get the value of x, which will be greater or equals to 0. And what does this mean? For us to get a greater or equals to 0, it means we are dealing with a number that is being positive. So it means if we want to get the answer here, we need to consider the part where there is positive sign. So it means this is where we need to get the answer. And what does it mean? It means that this expression will always be positive if you use values bigger than 2 or values less than minus half. So that's where we're supposed to get the answer. So which means that in most of the cases, guys, when you are dealing with inequality, it's either the answer it is in between two values or it's outside those two values. So if it's in between, what you do, we just say, okay, A, it's less than, like we are going to write the same sign, but they do not mean the same thing. It means X is greater than A, but less than B. We always do this if the answer is in between. But if the answer is not in between, it's outside, we just say X is less than the A, or the X is greater than the B. So, but the best way to remember this is to use your hands. If you use your hands like this is the left. Your right-hand side will be the greater, and your left-hand side will be the less than. So it means if it's greater, it's your right-hand side. So it means this is the right-hand side, and this is the left-hand side. So it means the left-hand side will be less than, the right-hand side will be the greater than, using your hands. So all the time you need to consider those two options. But looking at this expression, guys, we want the answer to be positive. And what does it mean? If we want the answer to be positive, it means we are going to consider where we have a positive sign. Remember, I said we consider the answer by looking at the inequality sign. So if it says, yet says greater, which means greater, we look where there is plus. But if it says less, it means we look where there is a minus. So it means it was going to be here. But now since it says greater, it means we look where the answer is positive. It's here and it's there. You see that it's not in between. And since the solution is not in between, it means we're going to use the right hand, the right hand and the left hand approach. So which means we're going to do this. We'll say, okay, fine. To get the answer, we'll say X or X. Then what do? We start with the left-hand side, and it will be less than. The right-hand side will be the greater. So now it means you're going to say, okay, fine. The less than, then you bring this value, it will be minus half. Then this side it will be 2. But since there is an equal sign there, it means we are including minus half, and we're also including 2. That is the answer for the inequality. But another approach, in most of the cases, some uses graphs, but we can still use graphs. There's no problem with that. In another way, we can use such notation to say we allow any value from, let me just use a different. So we allow any value from, let's say from negative infinity to positive infinity. Where is the answer? It means the answer is from, let's say, any value less than minus half and including minus half. And again, any value bigger than including. So you see that we can say, if you don't want to write in that, we can say from negative infinity, excluding from negative infinity to minus half up until here, or from 2, including 2 to infinity, which we are excluding. So it's one the same thing. It's either you're writing like this or like this. It's one the same thing. So that is the answer for 1.1.3. Remember, wafana, we usually call it wafana. So the less than is the left, the greater is the left, is the right hand. But you do this if the answer is not between, it's just outside the interval, then you do that. But if it's in between, then you always use less than. So you write the same sign, but with which will mean different things. So it's very important when you're dealing with inequalities. I believe you are following. Let's now continue with the next question. The next question, it says, the root of 2x plus 5 minus 3 divided by the root of 2x plus 5. We need to solve for x here. Obviously, this is one of the example, like it's one of the expressions that deals with SATs. And this is very important. Let's look at the question. It says the root of 2x plus 5, 3 over the root of 2x plus 5 equals to negative 2. So here, what you can do in order to remove these sides, we must first get rid of the fractions. We're actually having a fraction here. So to do that, we'll say, okay, let us let the root of 2x plus 5 to be something, can say k, which means wherever we see root x plus 5, we'll put k. And this will be k minus 3 over k equals to minus 2. That's over 1. But when you look at this expression, already there are fractions. So we need to be able to simplify fraction. And I believe you know how to simplify fraction. So we're going to do this. We'll multiply the denominator together. 1 multiplied by k is k. Then we cross multiply this one. What is k times k? It's k squared minus 1 time is 3. That is 3 equals to minus 2 over k. I'm saying minus 2 divided by 1 because we want it to be a fraction. Then we are going to cross multiply again. This will be k squared minus 3 equals to negative 2k. Then we'll write this in a standard form. So this will be k squared minus 3 equals to negative 2k. Let's rewrite this in a standard form. This will be k squared. Oh, I'm still repeating the same thing. I apologize, guys. So now, so writing this in the standard form, we'll have k squared plus 2k minus 3 equals to 0. Then 2 pairs of brackets equals to 0. Then k and k, factors of 3, that will give us 2. It will be 3 and 1. But to get positive 2, it means, here, since the same sign, it says minus, it means we have to have plus and minus. Let's confirm that. K times k is k squared, then positive, and we're going to have minus k plus 3k. Obviously, minus k plus 3k will give us 2k, which is the correct answer. So let's now solve for k. Then the k would be k is equals to minus 3 or k equals to 1. But however, we are not solving for k, we are solving for x. So remember, we said we have to let 2x plus 5 to be equals to k. So it means this will be the root of 2x plus 5 is equals to negative 3, or the root of 2x plus 5 is equals to 1. So we have to solve for x, not for k. And to do that, it means we need to square both sides. We need to remove the square root signs. So we need to square both sides here. And we square both sides. The same applies here. Square both sides here. Square both sides. So this will be 2x plus 5 equals to 9, or 2x plus 5 equals to 1. So let's solve for x. This will be 2x equals to 9 minus 5. It's 4. Or 2x equals to 1 minus 5. It's minus 4. So we divide by 2, then x becomes 2. Or x becomes negative 2. But this is not the final answer. This is not the final answer. Remember, when we're dealing with squaring both sides, we need to check the answer. Okay, just a minute, guys. Okay, now we can proceed. Right, here to check the answer, which means we have to take the value of x. Remember, the value of x here, we have 2 and minus 2. And to confirm if these are all true, it means we have to come to this equation. And we say, wherever there is x, we need to substitute this by either 2 or negative 2 to confirm if the answer on the left-hand side and the right-hand side are equal. Or let's do this. So 2 times, let's start with 2. 2 times 2 is 4, and 4 plus 5, that is 9. So this will be the root of 9 minus, then we have 3 there, over, but since the same equation will be the root of 9. So root of 9 is 3 minus 3 over 3, because this also root of 9 is 3. So this will give us 3 minus 1, which is 2. And you see that 2 is not the same as minus 2. It means this is not the correct answer. We restrict this. Now we come to minus 2. Minus 2, we do the same. With minus 2, where there is x, we put minus 2. So it means we're going to do the same. Okay, 2 times minus 2, this is minus 4. And since we have minus 4 plus 5, this will be 1. So you see that we're going to have the root of 1 minus 3 over the root of 1. This will give us 1 minus 3 over root 1, which is 3. 1 minus 3 is minus 2. So that this answer and this are equal, which means this is the correct one. So therefore we need to write the conclusion to say x equals to -2. So always when we are squaring both sides, when you're dealing with squaring both sides, you need to confirm your answers. You need to confirm your answers. I believe you are following. I believe you are following. So it means x is not equals to 2 and x equals to -2. So it means x equals to -2 is the correct answer in terms of this. So it's very important. Remember, practice makes perfect. Right, let's now move on to the next question. In the next question, it says solve for x and y simultaneously. So we need to solve for x and y simultaneously. Okay, fine. We're going to do this. Let's first write the equation. So our equation is y plus x equals to 2. Then let's call this equation number 1. Then the second one, it's x squared plus 3xy plus 8 equals to 0, equation number 2. Obviously, within these two equations, we need to start with the one that is not complicated. Obviously, we're going to start with equation number 1. So we're going to say from equation number 1, maybe we can make y the subject or x the subject. It does not matter. But for now, let's make x the y the subject of the formula. So making y the subject of the formula, this would be y equals to 2 minus x. I mean this equation. So we're going to call this equation number 3. So which means equation number 3 and equation number 1 are the same. So we're going to say substitute equation 3 into equation 2. What does it mean? It means in equation 2, where there is y, we substitute by 2 minus x. So we're going to use this. So we're going to have x squared plus 3x. Where there is y, we're going to put 2 minus x plus 8 equals to 0. Let's remove brackets. So it's x squared plus 3x times 2, it's 6x. 3x times x, that is 3x squared plus 8 equals to 0. Now, let's rewrite this to be in a standard form. Obviously, we have to group like terms. And looking at this x squared and x squared, these are like terms. So it will be x squared minus 3x, this will be -2 x squared, then followed by the bx, which is 6x, followed by the c, which is 8 equals to 0. And obviously, we still want to write this to be in a standard form. And to do that, we can see that there's a common factor of 2 here. So it means we can divide everything by -2. Or what we can do also, we can first multiply by negative or divide by -2. There's no problem. We can first, okay, let's multiply by -2. This will be 2x squared minus 6x minus 8 equals to 0. Then after that, we divide by 2. Dividing by 2, this will be x squared minus 3x minus 4 equals to 0. Then we're going to write this, we're going to factorize this expression. Factors of x squared here, it will be x and x. And remember, we want the sign should be different sign because it's negative. So factors of x squared here will have x and x. And factors of 4, that will give me 3 as the middle term, it will be 4 and 1. So since I said the sign must be opposite, so we're going to have negative and positive. Let's confirm. Remember, -4 plus 1, it's -3. 3. And negative times positive is negative. 4 times 1 is 4. It's 4, yes. So which means that therefore x equals to 4 or x equals to -1. But since the question says we need to solve for x and y simultaneously, it means we got the value of x, so we're in short of the value of y. And to do that means we'll go to equation number 3 and say, if x equals to 4, what is the y value? In equation number 3, where there is x, we put 4, so y equals to 2 minus 4, which is -2. Same applies when x equals to -1. We do the same. Y equals to 2 into -1. This will give us 3, which means as a coordinate, when x is 4, y is -2. And when x is 1, it's, I'm saying -1, y it's 3. So that is the answer. But by the way, we can still make x the subject of the formula. There's no problem with that. There's no problem with that. So we got x equals to 4 and y equals to -2, and x equals to -1 and y equals to 3. So that is the value of x and y. Right, let's move on to the next question. Moving on to the next question. Right. Moving on to the next question, what we have? We have the following. It says the roots, which are the x values, the roots of the equation f of x equals to 0 are given as follows. X equals to 4 plus or minus the root of 16 minus 4m into minus m plus 5 over 2m. Then the question says determine the values of m for which the roots, which is the x values, will be non-real. Okay, they want to know the values of x for which the roots will be non-real. So which means this fall under nature of roots. This falls under the nature of roots. So this is an example of nature of roots. All right, let me remind you about the nature of roots before we start answering this question. We know that nature of roots actually use something called discriminant, which we know that discriminant or delta, it's always equals to b squared minus 4ac. And this b squared minus 4ac, it actually comes from a quadratic formula. So the b squared minus 4ac, it actually comes from a quadratic. So it means this is our discriminant. It's a delta. Whatever it's in the root sign on a quadratic equation, that is the discriminant. It's the one that tells us the nature of the roots that we're going to solve. And we know very well that when discriminant is bigger than 0, it means the roots are real. But when the discriminant is equal to 0, it means the roots are equal. And when the discriminant is less than 0, it's negative, which means the roots are non-real. So we need to use these conditions to answer the questions, because it says, determine the value of m for which the roots will be non-real. We know that for non-real roots, to have a non-real root, for non-real roots, the discriminant should be less than 0. Discriminant should be less than 0. And by looking at the equation here, what is our discriminant? Obviously, the discriminant is an expression that is inside the root sign. That is our discriminant, which means we're going to say 16 minus 4m into minus m plus 5. This should be less than 0. So, okay, let me just use a visible. So we know that for roots to be non-real, the discriminant should be negative. So we need to determine the values of m that will make the equation to have non-real roots. And to do that, it means we're going to say, okay, fine. For non-real, discriminant should be negative. And what is our discriminant? Discriminant is the expression that is inside the root sign on a quadratic equation, which we have there is 16 minus 4m into minus 5 plus minus m plus 5 less than 0. Let's expand this to solve for m. Then we're going to have 16, remove brackets here, plus 4m squared minus 20m less than 0. I believe you're following. Also, just multiplying in here. So let's write this to be in a standard form where 4m squared minus 20m plus 16 less than 0. Yes, it is in a standard form, but it needs to be simplified. Let's look for a number that goes into 4, 20, and 16. It's 4. So we're going to divide everything by 4 here. So this will be m squared minus 5m plus 4 less than 0. So we'll factorize because this is an inequality, less than 0. Factors of m squared, it's m and m. Factors of 4, that will give us 5. It will be 4 and 1. And let's look at the sign here. It says positive, it means you have to use the same sign. So, but to get negative 5, it means we have minus and minus, because minus 4 minus 1 is minus 5. So already we need the critical values because this is an inequality. So what are the critical values? We have m equals to 4 or m equals to 1. So let's draw a number line. The number that comes first on number line, we have 1 and 4. And any number bigger than 4, here it's 5. Let's try to substitute here. 5 minus 4 is a positive number. 5 minus 1 is a positive, and positive times positive is positive. So it means any value that is bigger than 4, the answer will be positive. And as a rule of thumb, if we have positive here, then we're going to have negative, and then we're going to have positive. You can still confirm. For example, any value that is between 1 and 4 is 2. If you substitute here, 2 minus 4, it's negative 2. And 2 minus 1 is positive. So you see negative and positive, it's negative. So we can still confirm that. But now, remember we said we take the decision of the solution based on the inequality sign. And what is our inequality sign there? Our inequality sign says negative, so less than. So less than means the answer is where there's negative. And what I said, if you're writing that, it's either the answer is in between or it's outside. So if that, because here the answer is negative, the answer is in between, so we're going to say the m should be between 1 and 4. But since there is no equal sign here, so it means the m should be between 1 and 4. It means for the roots to be non-real, we need to use value of m that is between 1 and 4. And another way to write this, we can say m is an element from, no, not including, from 1 up until 4, because there's no equals to there. That's why if you can say this, remember the only way to have non-real in roots when we have SATs, it's when the expression inside the SAT is negative. I apologize. For example, give me any value that is between 1 and 4, the m. For example, if m is 3, let's substitute where there is 3, where there is m, especially in the root sign. So this will be 16, the root of 16 minus 4 into 3 into minus 3 plus 5. Obviously, this will be the root of 16 minus 4 times 3 is 12, minus 3 plus 5 is 2. So you see that we're going to have 16 minus 12. So 16 minus 12 times 2, which is 24. It will be negative 8. And what is the root of negative 8? It's non-real. So that's why it says we need to use values of m that are between 1 and 4. Then the roots will be non-real. The roots will be non-real. Nature of roots. So if you can check here, we have addressed equations and inequalities. We also address the equations and inequalities and also the nature of roots. Then what is the next question here? The next question, it says you must show that the maximum value the maximum value of the root of minus x squared, it's 4. There are many ways to skin a cat. We want to show that the maximum or the highest value of the square root of negative x squared, negative x squared plus 4x plus 12. This has a maximum value of 2. So actually, to work this out, we're actually interested on the expression that is inside the root sign. We can do this in 2 ways. We can say, okay, fine. If we want to maximize or to get the maximum value of this, we must know what is the maximum value of the expression that is inside the root sign. And to do that, we can say, okay, fine. We have minus x squared plus 4x plus 12. We can do this in 2 ways. We can say, okay, fine. Let us now take this as the parabola. It's a quadratic equation, so it's a parabola. And we know that in terms of a parabola with the ax squared plus bx plus c, if the a is a number bigger than 0, the graph is smiling. And if it's a it's a number less than 0, the graph has a set face. But by looking at this, the a, which is the coefficient of x squared, it's less than 0. Which means this graph will have a set face. And we know very well that where there is a set face in a parabola, we'll always have a maximum turning point. So we can do this. We can say, if we know the turning point of this parabola, we'll be able to know the maximum. And how do we find the turning point of the parabola? We can get the turning point of a parabola by using axis of symmetry. And what is that? X equals to minus b over 2a. The b here is given as positive 4. So we're going to have 4 over 2 into the 8, negative 1. So this will give us minus 4 over minus 2, which is 2. So we know the value of x here. That will give us the maximum turning point. So how are we going to do that? Usually we need to take this value and substitute into the equation to get the value of y. Let's do this. Let's say where there is x, we have x squared plus 4x plus 12. Where there is x, let's substitute by 2. So this will be minus 4 plus 8 plus 12. This will give us 16. So it shows that the turning point of the graph is 2 and 16 here. And it means the graph will have the highest point when the maximum value of 16 on a parabola. And to do that, if we take that, we know we want the maximum value of this expression. And we know that in a parabola, if x is 2, then it means where there is x, we can substitute by 2. Plus 12. So what is that? This will be the root of 16. And what is the root of 16? It's 4. You see that the maximum value of this expression is 4. It's just that because this for grade 11, we'll not talk about something called calculus. Calculus can also be used, but particularly for Elena who's in grade 12. Then Elena who's in grade 12 can still use calculus. But you guys, since you're in grade 11, you cannot use calculus to check, to show that the maximum value of this expression, it's actually 4. Another way would be the issue of using, what is this? Let me say, completing the square. If we do not want to use that, we can still use completing the square. So, okay, fine. Remember, we want, what do you want? We want, okay, we can let's say P to be equals to the root of minus x squared plus 4x plus 12. And to do that, we can say, we can multiply this become p squared. I'm saying we put the root sign. So it will be p squared equals to minus x squared plus 4x plus 12. And we know when we are completing the square, the square root, the coefficient of x squared should always be 1. But here we have -1. So what can we do? To make it 1, which means we're going to say minus into. And we just take the negative as a common factor. So we're going to have x squared minus 4x minus 12. Then from here, we need to take the coefficient of x. Here it will be -4. We multiply that by half, we square it and work it again. This would be -2 squared, then it gives us 4. So it means the p squared here, it will be minus into, we write this will be x squared minus 12x minus 12 minus 12. Okay, let me check something. Oh, minus 12. Okay, actually, I should do this. Remember when we are dealing with squaring both sides, we add and we minus at the same time. So this will be minus x plus the 4, this 4, minus 4, then minus 12. So we can rearrange this to be minus into, then this becomes x squared minus 4x plus 4. We group this together. Then minus, oh, sorry, this was minus, then minus 16. And after doing this, then we can make 2 brackets for this expression only with minus 16 outside. So this will be x and x. Then the factors will be -2, -2, and -2. So this will be minus into. So we'll have x minus 2 squared minus 16. Then we multiply everything by negative. So we'll have minus into x minus 2 squared plus 16. You see that this is in the form of y equals to a into x minus p squared. So this is the q. The q is the one that will be there. So now we know that the maximum value of p squared is 16. So which means if we put the root sign, then the maximum value will be 4. So that's why we have shown. We have shown the answer. I believe you're following. Right, let's now move on to the next question. So we've addressed the issue of algebra together with, actually the algebra part. So let's move on to the next question. The next question, it says simplify fully without using a calculator, that is exponents. We need to simplify this fully without using a calculator. To do that, right, we know that the law of exponent means this expression here can be written as 2 to the exponent of x times 2 to the power of -3, minus 3 times 2 to the exponent of x times 2 to the exponent of 1, divided by this other one will be 2 to the exponent of x times 2 to the power -2. So let's now simplify this. Now, if you look at the numerator, we have something common there. Okay, what is the common factor? The common factor here, you can see that the common factor is 2 to the exponent of x, both sides. So if you pull that as a common factor, we'll have 2 to the exponent of x, then we'll remain with 2 to the exponent of -3 minus 3 times 2, that is what we're left with, divided by 2 to the exponent of x times 2 to the power -2. And this will divide these two. And when they divide, means you're going to remain with, we know in terms of exponent, where we have negative exponents, if we say we have x to the power -n, this is the same as 1 over x to the n. So we're going to use it here. So it means this is the same as 2 to the power -3 minus 3 times 2, which is 6, divided by. Same applies 2 to the power -2. Let's change this. This will give us 1 over 2 to the exponent of 3 minus 6, divided by 1 over 2 to the exponent of 2. I apologize, there's a 2 here. So if we expand this to the exponent of 3, that is 1 over 8. It's 8 actually, minus 6 over 1 over 4. So we expand this by using our fraction. It means this will give us minus 47 over 8. Divide by 1 over 4. So we'll change division to multiplication. It's just going to have minus 49 over 8 times 4 over 1. And to simplify this, we can say, since there is multiplication, it means now we can say 4 into 4 goes once, 4 into 8 goes twice. So it means the final answer here is minus 47 over 2. So minus 47 over 2 is the final answer. Remember, practice makes perfect. All right, let's now move on to the next question. The next question says solve for x. We need to solve for x here. Still exponents. Let's start with the first one. It says 2 minus 16 x to the exponent negative 3 over 2 equals to 0. We need to make x the subject of the formula. And obviously to do that, we can do this. We can first, either we transpose 2 to the right hand side, it's going to remain with minus 16 x to the power minus 3 over 2 equals to minus 2. Then from here, we divide both by negative 16. This will be x to the power negative 3 over 2 equals to 1 over 8. Then we can simplify this to say, okay, fine. We have x to the exponent minus 3 over 2 equals to, this is the same as 1 over 2 to the power of 3. So since here we want to remain with x, it means we have to multiply by the reciprocal of this, which is minus 2 over 3. And what you have done this side, you must also put it 2 over 3. So by so doing, remember when let's say you have half and you multiply by 2 over 1. So it will become 1. That is what we have done there. So which means now the value of x here will remain with x, will be x the exponent of 1. Then here when we work it out, this will be, if we were to multiply this, it will give us, actually it will be 2 to the power minus 3 to the exponent minus 2 over 3. We can now multiply the exponents. So it means this will give us 2 to the power of 2, which is actually 4. So it means x equals to 4. But this is not the only approach. Another way we can do this, we can say, okay, since we have 2 minus 16, it's x to the power minus 3 over 2 equals to 0. We can still leave the 2 this side becomes the c, 16, then we have x to the power minus 3 over 2. Then we can change this exponent to still have a positive exponent. And do that means we can say, okay, fine. We have, this is the same as 2 equals to 16 over x to the exponent 3 over 2. That's over 1. Then we cross multiply. And this will be 2 to the exponent 3 over 2 equals to 16. Then we divide by 2, it will have x to the exponent 3 over 2. 16 divided by 2 is 8. I mean to say 8. And since we have 8, it means we're going to say, okay, fine, it's x to the power 3 over 2. So it means you have to multiply by the opposite of 3 over 2, which is 2 over 3. The same applies here, it will be 8 to the exponent 2 over 3. So since this expression, it's 1, we're going to have 1 equals to 8 is 2 to the power of 3, everything to the power of 2 over 3. Then we are allowed to multiply the exponents. So what is 3 multiplied by 2 over 3? Obviously, it will be 2. So it will be 2 to the exponent of 2, which is still. So it means x equals to 4. It's just another way of getting it. I believe you're following. I believe you're following. Okay, let's move on. Okay, the next question, we're given 4 to the exponent of x, 4 to the exponent of x, plus 8 equals to 9 to the exponent of 2. We need to solve for x. Right, let's do this, guys. We have 4 that is raised to the exponent of x, plus 8, which is equals to 9 times 2 to the exponent of x. Now, there's something that we need to consider here. Since in between there we have a plus, and there is an exponent, the exponent here is x to the power of x. So the exponent is x, which means we have to say, okay, fine. What is the base where the exponent is? It's x. It's base. There's 2 and there's 4, but we can still expand 4 to have a base of 2, which means this is the same as 2 to the power of 2. Everything to the power of x, plus 8 minus 9 times 2 to the power of x equals to 0. We know that under the law of exponent, if we have this one base but with multiple exponent, we are allowed to multiply the exponents together. So it means this is the same as a to the exponent of x times y. So it means we can multiply the 2 and the x here. This will be 2 to the exponent of 2x. Let me regroup this: minus 9 times 2 to the exponent of x plus 8 equals to 0. But we know very well that when we have 2 to the exponent of x times 2 to the exponent, this is the same as 2 to the exponent of 2x, because the base are the same, and it's still the same as 2 to the exponent of x and all squared. So since we have here, we have 2 to the exponent of x, it means here we need to repeat 2 to the exponent of x 2 times. So this will be 2 to the exponent of x in all squared, minus 9 times 2 to the exponent of x plus 8 equal to 0. So you see that we have 2 to the exponent of x here and 2 to the exponent. So we can do this. It's either we factorize or we let. So let us let where there is 2 to the exponent of x to be k. It's just an example. So it means wherever we see to the exponent of x, we're going to put k. So this will be k squared minus 9k plus 8 equals to 0. Then we factorize. Factors of k squared is k and k. Factors of 8, that will give us 9, and when the sign must be the same because we're using plus. So it will be negative 8 and negative 1. That's why negative 8, negative 1 will give us minus 9. So it means the value of k here, it's k equals to 9 or k equals to 1. It's giving us minus 1, but it's also giving us positive 8. But by the way, we are not solving for k, we are solving for x. So it means using this information here, we can go back and say, we know that 2 to the power of x is k. So which means now we can say 2 to the power of x, it's 9. Or, no, it's 8, no, not 9, I apologize. It's 8. It's 8 or 2 to the power of x, it's 1. Now, since here we know that when the base are the same for equality, it means the exponent are also equal. So it means this is the same as 2 to the exponent of x equals to 2 to the exponent of 3, which is 8. Or 2 to the power of x, since we have 1 here, we know that any number to the power of 0 is 1. So this can be 2 to the power of 0. So since the base are the same, then we can say x equals to 3 or x equals to 0. So this is the answer for that question. So that is the answer. I believe you guys are following. Remember, practice makes perfect. Right, let us move on, ladies and gentlemen. Okay, the next question, it says, oh, we still have to solve for x. So let us go through this. We are given the nth root, I'm saying the x root of 9. Okay, let me use a different color. The x root of 9. The x root of 9. Okay, let me just erase this. The x root of 9 is the issue of signs. Okay? Okay, just a minute. All right, we're gonna do this. We'll say so we have the x root of 9 equals to 243. And we know very well that when we are dealing with SATs, this is SATs, we know that the square root of any number is that number, the power of, which means the nth root of an expression is that expression to the power of 1 over n. So which means we're going to use this principle here to say the nth root of 9, this is 9, I apologize, 9 to the exponent 9 to the exponent of 1 over x equals to 243. Now, we need to solve for x, ladies and gentlemen. And to do that, it means it's either we try to look for a value that will have a base of 9, but which equals to 243. I don't think so. Because we know that 243 is the same as 3 to the power of 5. 3 to the exponent of 5 is 243. Which means we can do this, we can simplify. Here, it's either we rewrite this to say, okay, 9 to the exponent of 1 over x. Then we multiply by the reciprocal of this, which is x over 1. And whatever we apply this side, we must also do it this side. I believe you're following. And this will result to this. Remember, this would be 1. So we'll have 9 equals to 9 equals to, then now 343 we can now substitute as, I'm saying 243 is the same as 3 to the exponent of 5, but everything to the exponent x over 1 is just x. Now we can rewrite 3 to have a base of 3. This is 3 squared equals to 3. Now we are allowed to multiply exponent, that is like a base that is multiple exponents. So this is the same as 8 to the, so this is the same as 5 times x, this will give us 5x. But now, since the base are the same, we can now equate the exponents. It means 2 equals to 5x. And we divide by 2, it means the x is equals to 2 over 5. So that's why if we say, what is the 2 over 5th root of 9? Let's confirm that. To give us 243. So that is the answer. So the answer is 2 over 5. I believe you are following. Okay. Now let us move on. Practice makes perfect. Okay, then next question, what do we have? It's still exponents and surds. Let's just go through the question. It says, simplify fully. We have the square root of p squared minus q squared times p plus q to the exponent of 5/2 divided by p minus q to the exponent of half. Remember, there are many ways to skin a cat. So what we can do, we can, okay, first let's work with the expression that is in the surds here. We know that the square root of any expression is that expression to the power of half. So it means we can expand this to say this is the same as p squared minus q squared, everything to the exponent of half, times p plus q to the exponent of 5/2 divided by p minus q to the exponent of half. But when we look at this, p squared minus q squared, this is the difference between two squares. And we can factorize this because we know p squared minus q squared is the same as two pairs of brackets, the p and the p, the q and the q, the minus and the plus. Can still confirm that. It will still give us this. So it means now we can say, now we can expand this to be p minus q times another p plus q, but everything to the exponent of half, into p plus q to the power 5/2 divided by p minus q to the power of half. But for these two only, we know that a times b to the exponent of n. This is the same as to the exponent of n times b to the exponent of n. So it means we can expand this to be p minus q to the exponent of half, p plus q to the exponent of half, and p plus q to the exponent of 2 divided by p minus q to the exponent of half. By the way, in between here we have multiplication. So it means we are allowed to divide the terms that are actually the same. So you can easily see that the p minus q to the exponent of half will divide with the p plus q minus p minus q to the exponent of half. So what are we going to remain with? We'll be remaining with p plus q to the exponent of half together with p plus q to the exponent of 5/2, if I'm not mistaken. So it means we'll have p plus q, okay. So we'll be remaining with p plus q to the exponent of half times p plus q to the exponent of minus, I'm going to say 5/2. Now the bases are the same. The bases are the same. We know that if the bases are the same, we take one base, which is p plus q, and we add the exponent, so it's going to be half plus 5/2. Let's rewrite this. Then what is half plus 5/2? The half plus 5/2, this will give us 4/2, which is just 3. No, 6/2, I'm to say 6/2, which is just 3. So it means this is the final answer. So this will be p plus q to the power of 3. P plus q to the power of 3. That is the final answer. Remember, there are many ways to skin it. So it means here we're actually using surds. Surds are very important. Remember, we must know that when we're dealing with surds and exponents, is that the square root of a times b is the square root of a times the square root of b. And the square root of an expression is that expression to the power of half. So it's very important to know that. I believe you are following. I strongly believe you are following. Okay? Now we can move on to the next question. Right. What is the next question? Right. It says, question 3, this is number pattern. Given a linear pattern, grade 11s, given a linear pattern, we know that when we are dealing with a linear pattern, which in grade 12 we call it a geometric sequence, a linear pattern has a general formula of Tn equals to A plus n minus 1 times D, where D is the common difference. So here already we have 7, we have 2, we have minus 3, we have 3 terms. And to check that this is a linear pattern, we need to subtract the terms. But how do we subtract the term? Term 3 minus term 2 and term 2 minus term 1 and also term 3 minus term 2. So we're going to say T2, which is 2 minus 7. This will give us minus 5. And minus 3 minus 2 will give us minus 5, which means this linear pattern has the first term of 7 and a common difference of minus 3. So it means, I'm saying minus 5. Every term it's subtracted by 5. So you subtract 5 from the previous term to get the next term. So we have that. So this will be minus 5. So the first question says, determine the general term of the linear pattern. Obvious to do that, I've already explained. So it means 3.1.1, we say Tn, it's A plus n minus 1 times D. So what is the A? The A, 7 is the first term. Then the D, it's minus 5. So it's the same as plus into n minus 5, n minus 1 into minus 5. So let us now remove the brackets. This will be 7. We multiply in by negative 5 here. So this will be negative 5n plus 5. Let's rearrange this. So this will be minus 5n plus 12. Or 12, which is the same as 12 minus 5n. It's the same. So let's do this. Let's test if this is the correct one. To test that means where there is n, we first put 1. Remember, we want to check term number 1. Obviously, where there is n, if we say 12 minus 5 times 1 will give us 7. So if it means if we want to check term 2, we substitute by 2, it will be 2. Then just like that, term 3, it will be minus 3, which means this is the correct general formula. So the Tn is equals to 12n minus 5n, or 5n minus 5n plus 12. There's no problem. So what is the next question? The next question says calculate term 20. And to know the value of term number 20, we want term 20 means where there is n, we put 20. So it will be 20 is 12 minus 5 times 20. So this will be 12 minus 5 times 20. It will be negative 88. Which means term number 20 in this sequence would be negative 88. I believe you're following. I believe you are following. I strongly believe you guys are following. So negative 88. So that is term number 20. Then the next question says, which term in the pattern has this value? So it means we want to know that if the first term is 7, second term is 2, Third term, it's minus 3. Which of the term in this sequence or pattern will have a value of 138? It means we want to know which of the term. And to do that means we'll say, okay, fine. We want Tn, the n which will give us a value of 138. And to do that, since we have the general formula, it means we'll say, okay, fine. Where there is Tn, we'll put 12 minus 5n, it's minus 138. We want to make n the subject of the formula, so it means we'll say minus 5n, then we transpose 12 to the right-hand side. It will be minus 138 minus 12, because it was positive. So this will give us minus 5n equals to minus 138 minus 12. This will be minus 150. Then we divide both by negative 5. Dividing by 5, obviously will give us 30. So it means it will be term number 30. Term number 30 is the one that will give us a negative 138. We can still confirm that in the equation where there is n here, we substitute by to confirm. So it will be 12 minus 5 times 30, it will give us 138. So we have answered the question. We have answered the question. That is term number 30. Then now let us move on, ladies and gentlemen. Then 3.2, it says, given 6, 2x plus 1, and 3x minus 3 are the first 3 terms of a linear pattern. They are the first 3 terms of a linear pattern. Then determine or calculate the value of x. We know that if we are given this pattern as 6, 2x plus 1, and 3x minus 3. The 6 here is the term number 1, term number 2, and term number 3. Term 2 is 2x plus 1. So if this is a linear pattern, they must have a common difference. So which means if we take term number 2, we subtract term number 1. The answer should be the same as we take term number 3, subtracting term number 2. If it's a linear pattern. But now, what is term number 2 is 2x plus 1. Minus term number 1, since it's one term, it's 6, equals to term number 3 is 3x minus 3. Minus, we need to put a bracket here because we'll be having 2 terms, which is 2x plus 1. So let us now simplify this. This will, by grouping like terms, we'll have 2x minus 5 equals to, let's remove the brackets, 3x minus 3 minus 2x minus 1. So we'll have 2x minus 5 equals to, let's remove brackets, 3x minus 2x, this will give us x, minus 3 minus 1 is minus 4. Still we'll have to group the like terms again. So it means you have to transpose the x2 to the left-hand side. This will be 2x minus x. Same applies to transpose 5 to this, so it will be minus 4 plus 5. I believe you're following. 2x minus x, it's x, minus 4 plus 5, it's 1. So it means that to have a linear pattern, the value of x should be 1. I believe you are following. 2x minus plus 1 minus 6, 3x minus 3, minus into 2x plus 1. I'm just confirming. 2x minus 5, 2x minus 3, then minus 2x minus 1. Then this gives us to give us x minus 4. Then we move this side. Okay, it's fine. So it means if where there is x, we can substitute by 1. It means we're going to say 6. 6 will be the first one. So where there is 1, 2 times 1 is 2 plus 1 is 3. Same applies. 3 times 1 is 3 minus 3 it's 0. So let's get the difference here. 3 subtract 6, it's minus 3. 0 subtract 3, it's minus 3. See, this is a linear pattern. It is a linear pattern. I believe we are following. I believe we are following. But here we are not given a quadratic pattern. Remember, in grade 11, you only talk about linear and quadratic pattern only. Okay, so it means I will look for other questions where we'll address quadratic number pattern. I believe you are following. So we've answered question 3. Now we can move. Oh, date is another one. Okay, I was not aware of that. So it means there's no need for us to look at in the other questions. Right, it says the quadratic number pattern for P, 11, Q, and 22 has a second difference of 2. We know very well that, ladies and gentlemen, when we are given a quadratic pattern, here we are told that we have 4, we have P, we have 11, we have Q, and we have 22. The first term here is 4, second term is P, third term it's 11, fourth term it's Q, fifth term it's 22. If this is a quadratic pattern, the first difference, the answer should not be the same. But the second difference, that's where the answer should be the same. But they've told us that there's a common second difference of what? Of 1. And to do that means we're going to sort of fine. We know first difference, we take T2 subtract T1, T3 subtract T2, just like that. So what would be the first difference here? Sequence. T2 is P minus 4. This would just be P minus 4. Let me put it in bracket. This one will be 11 minus P in bracket. This one will be Q minus 11 in brackets. This one will be 22 minus Q in bracket. Is this the first difference? But we are told that in the second difference, these values, when we subtract them, they're always giving us 1. They give us 1 because this is the second difference. They give us 1. Okay, so it means now the first question says, show that P is 7 and Q is 16. Straightforward. Remember, we are told that when we do the second difference, the answer is always 1. What does it mean? It means if I take this sequence and this one and that, if I take this and subtract this, the answer should be 1. This one subtract this, the answer should be 1. So it means, let's do it in that way. It means if I say 11 minus P, subtract P minus 4, this should be 1. And this is not the only way. Again, if we take Q minus 11 in brackets, we subtract 11 minus P, still the answer will be 1. So let's now expand this. This will be 11 minus P, remove brackets, minus P plus 4 equals to 1. Group like terms. 11 plus 11 and plus 1, this gives us 15. 15 minus 2P equals to 4. Let me say, I apologize. Equals to 1. Then we have to make P the subject of the formula. So this will be 15 minus 1 equals to 2P. Or we can say, we can do this, there's no problem. We can leave the negative 2P this side as negative 2P, then we move 15 to the right. So it's 1 minus 15, which is minus 14. Then divide by negative 2, the P is 7. So we got P equals to 7. But since P is equals to 7, we can now get the Q. And to do that means we have to either use this second part to say, okay, fine. We know that when we take Q, we subtract 11, we take 11, we subtract P, the answer is giving us 1 also. So let's simplify this. It means this will become the Q minus 11, remove brackets, minus 11 plus P equals to 1. Right, then we can now do this and say, okay, fine. The Q minus 22 plus P equals to 1. We know the value of P. So it will be Q minus 22 plus 7 equals to 1. Let's move it this side. So this will be, the Q will be 1 minus 7 plus 22. So 1 minus 7 plus 22 will give us 16. So it means the Q is 16 and the P is 7. So we got the value of P and we got the value of Q. Remember, practice makes perfect. And this is not the only approach. This is not the only approach. We can still do this. Let me show you another way. We can still say, because we know that there's a second difference of 2, it means this is always 2a. Oh, by the way, this was P minus 4. And this, it's because the first term in the first difference is the 3a plus b. And this one, it's in the first term is the a plus b plus c. So what we can do, we can still do this as okay, fine. The 2a is equals to 1. We divide by 2, then the a becomes half. And since the a is equals to half, ladies and gentlemen, we can now take our quadratic equation and say, the quadratic equation given here, it says Tn is an squared plus bn plus c. So now where there is a, we put half. So it's going to be half n squared plus b plus c. But we'll still get the answer, but there will be a lot of method here. Then what we can do is, where there is n, maybe we can put 1. Term number 1, it will be half into 1 squared plus b plus c. Then term number 1, we know it's 4. Then this becomes half plus b plus c. Then now we transpose the half this side. So 4 minus 0.5. So this will be 7 over 2 equals to b plus c. So this will be equation number 1. And remember, we have both be unknown, like we have two unknowns there. We do the same, maybe with a value that we know. For example, term number 11 we know. I'm saying term number 3 it's 11. So it means where there is n, we put 3. So it's 3 equals to half into 3 squared plus b into 3 plus c. So term number 3 we know it's 11. 0.5 into 9. This will be 9 over 2 plus 3b plus c. Then we transpose. So 11 minus 9 over 2. This will give us 13 over 2. It will be 3b plus c. So you see, we have two equations. So we're going to solve this simultaneously, either by elimination or substitution. So we're going to have b plus c equals to 7 over 2. Equation number 1. 3b plus c equals to 13 over 2. Equation number 2. So if you want to eliminate one, we can say, let's say we take equation 2. We can even use substitution. So 3b minus b, this will be b. C minus c is 0. So what is 13 over 2 minus 7 over 2? This will be 3. So we have the b of 3. So if we know the value of b is 3, we can either substitute here to get the c or there. So let's put it here. Then this will be b plus c, it's 7 over 2. Then it's going to be 3 plus c, it's 7 over 2. What is the c? The c is 7 divided by 2 minus 3. It will be half. So already we know the general equation. So we're going to have Tn, it's half n squared plus 3n plus half. But since we want the value of p is the second term. So it means when there is n, we can put 2. So it will be 0.5 into 2 squared plus 3 into 2 plus half to give us 2. I think there's a typo here. Okay, term 1 it's 4. Okay, 3 times 2.5. 7 over 2 is 3. It's half. Okay. Okay, let me check something. 1, 2, 3, 10, 8, 11. Minus 2, 13 over 2. There's nothing wrong here. Okay, let me check something. 2, 3. 3 squared. 3, 3. It's 14, something's wrong. So it needs somewhere here. We need to correct it. Okay, yeah, I think I've substituted correctly. Half. Term 1 is 4 minus. So number 2 plus b plus c. Okay. Oh, okay. Now I see. Well, that's the problem. We said 3b minus b. We said instead of 2b, then we said it's b. So divide by 2, it means the b is the one which is 3 over 2. Okay. The b equals to 3 over 2. So it means here I have to put 3 over 2. Then 7 over 2 divided by 2. This will give us 2. Okay, let's do the corrections here. Yes, because I can see that something is wrong here. So now what is the b? The b becomes 3 over 2 and the c it's 2. Let's now put 2. So 0.5 into 2 squared plus 3 over 2 into 2 plus into 2. Okay, sorry guys. Into 2 plus 2. This gives us 7. So it means term number, this one is 7, so it's correct. And Q is term number 4. We can put 4 where there is n there. 4 and 4. It will still give us 16. So there are many ways to skin a cat. So we got the same value. Right, let's now continue with the next question. So the second question says, determine the general term of the quadratic pattern. So we want the formula actually. Determine the general term of the quadratic pattern. So let us do that. Right, to do that, we have shown the value of P and Q. So now it means in our pattern, we're going to say, okay, for the Q, the P, it's now 7 and 11. The Q, it's now 16 and 22. Let's now get the difference. This is 3, 4, and 5, 6. So those are the values. Then now first different it's 1, it's 1, it's 1. So we know that the second different is always our 2a. Then the first term in the first difference, it's our 3a plus b. And the first term in the quadratic, this is our a plus b plus c. So since we want to get the general formula, the an squared plus the bn plus c, already I've confirmed what is we're going to get. So we'll say 2a should be equals to 1, then we divide by a, then the a becomes half. We got it? Then 3a plus b equals to the first term in the first, which is 3. So where there is a, we substitute by half plus b equals to 3. So this will be 3 over 2 plus b equals to 3. Then the b becomes 3 minus 3 over 2. And this will give us how much? 3 minus 3 over 2. This will give us 3 over 2. Then with the c, we're going to have a plus b plus c equals to 4. Then the 8's half. And the b is 3 over 2c. And now half plus 3 over 2, this will give us 2. So it means the value of c will be 2. Then now it means our equation now is Tn, the a is 1 over 2n squared. The b is 3 over 2n, and the c is 2. We can still confirm by substituting by 1 where there is n. Still it will give us 4. So this is the general formula. So we've answered these two. And the second question says, which values of n is Tn equals to 2, 3, 2? So it means in this sequence, there is a value, there is a term which gives us a value of 3, 2, 3. And to do that, we're going to do this. We have to solve algebraically. Now we have the general formula. So it means when there is n, like we want the n when the value is 2, 3, 2. So we are going to solve for that. So we're going to have Tn is equals to half n squared plus 3 over 2n plus 2. So now we know the Tn now it's 2, 3, 2 equals to half n squared plus 3 over 2n plus 2. So we need to first, okay, let's take the 3, 2, 3 this side. So we're going to remain with 0. It's half n squared plus 3, 2, 3, n plus 2 minus, let me say 3 over 2, n plus 2 minus 2, 3, 2. So now we need to get rid of this fraction. So we can do this, we can say 0. It's either we multiply everything by 2. Okay, before doing that, let's simplify this. Half n squared plus 3 over 2n minus 230. Why? Because it's 2 minus 232. So let us work out this. Let's multiply everything by 2 or divide everything by half just to get rid of the fraction. It means by so doing, we're going to have this. I can do away with this. So it means we'll have this. It's either we multiply everything by 2 or we divide by 2. So we're going to have 0 equals to, when we multiply by 2, this will be n squared here. By 2, it will be 3n. And by 2, it will be 230 times by 2. It will be 1,380. By 2, not by, oh, I've multiplied by 2, by 6 instead of multiplying by 2. I apologize. This will be 460. 460. So now we need to solve this. So we're going to have n squared plus 3n minus 460 equals to 0. We can either use factorization or quadratic formula. So you can use factors, but when you're using factors, you must say n equals to minus b plus or minus the root of b squared. So I'm not going to use that. I'm going to factorize. So the factors of 460, the factors of n squared is n, and here we have a minus, so it means we have to use opposite side. So we're going to have a plus and minus, but we want to get positive 3. So factors of 460 it will be 23 and 20. 23 and 20, let me write this again correctly so that you can see it. So in terms of factorization, we'll have this. So it will be n plus 23 and n minus 20 equals to 0. Because look, 23 times 20 is 460. And plus 23 minus 20 is plus 3. So which means the n equals to negative 23 or n is equals to 20. But we're not going to take this because we don't have a negative term. So it means this will be term number 20. That's why if you can substitute by 20, where there is half into 20 squared plus 3 over 2, which is 1.5 into 20 plus 2, it will give us 232. So we know that that will be term number 20. Then it says, if the sum of two consecutive terms, if the sum of the sum means addition, if the sum of two consecutive, what do you mean by consecutive? Consecutive terms are terms that are following each other. For example, T1 and T2, these are consecutive terms. T3 and T2 is also consecutive terms. So they are telling us that the sum of the two consecutive terms in this pattern, it's 1,227. Calculate the difference between the two terms. Calculate the difference between the two terms. We need to understand something here. And this is very, 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 very important. What is our general formula? Let me write down the general formula, ladies and gentlemen. General formula is Tn is equals to half n squared plus 3 over 2n plus 2, if I'm not mistaken. Okay, then now, in that case, we'll say, the question says, since we know that the first term is 4, followed by 7, followed by 11, followed by 16, followed by 32. They're saying in this term, in this sequence, the sum of two consecutive terms within this sequence, they add up to 1,222. So it means there are terms, there are consecutive terms between this pattern, which adds up to 1,000 and 1,122. We do not know those terms. We don't know whether it's Tn or is the next term or whatever, or the previous term. So let's do this. We say, okay, now we are talking about the sum of the two consecutive terms in this pattern. So we say, okay, let's assume the first term or the term that we're looking for is Tn. And each consecutive term will be the next term. Obviously, that will be Tn plus 1. Why am I saying this? Look at this. If we say we have term number 20, what will be the next term? That would be term number 20 plus 1, which is 21. So it means if this is n, it means the next one will be n plus 1. So what does this mean? It means we want to say, okay, there is Tn plus 1, such that when we take this Tn with the what? With the Tn plus 1, the answer would be 1,227 inside this quadratic pattern. But now look at these guys. The question says, if the sum of the two consecutive terms is 1,227, calculate the difference between those two terms. Obvious, to get the difference means we must know their values and we subtract them to know what is their difference. And to do this, it means we must know which term, which are those two consecutive terms which are adding up to 1,222. I believe you are following. Right, ladies and gentlemen, let me try to solve this in the other platform so that we can understand each other. Let me stop sharing this. We know the formula already. Okay. All right. My apology. Okay. Oh, I have to move this. Right, I want to write all the information here so that you can understand. So what is our formula, by the way? The formula, it was Tn equals to half n squared plus 3 over 2n plus 2. Now we want two consecutive terms, which I said is Tn, and the next one is Tn plus 1. So then we'll say, we know we want these two terms, Tn plus 1, and even Tn to add up to 1,227. So we're going to do this. Already we have the Tn. And what is Tn plus 1? It means if, for example, if we have, okay, we have Tn, this is our Tn. What is Tn plus 1? It means where there is n, we put Tn plus 1. So we'll say Tn plus 1, this is 1,227. So with the Tn, we know it's 1 over 2 into n squared plus 3 over 2n plus 2 plus, what is Tn plus 1? Where there is n, we put n plus 1. This will be squared 3 over 2 into n plus 1 plus 2. This must add up to 1,227. But we can still simplify this. We know that n plus 1 squared is the same as n plus 1 times n plus 1, which is just n squared plus n plus 2n plus 1. So we're going to have 1 over 2n squared plus 3 over 2n plus 2 plus half into, we do the substitution, this is n squared plus 2n plus 1. Remove brackets here, this will be 1. I'm saying 3 over 2n plus 3 over 2 plus the 2 minus 1,227 equals to 0. We need to group the like terms here. Like, okay, we'll have half n squared plus 3 over 2n plus 2. Remove brackets. Half n squared plus half times 2 is just 1. So it's n. Half times 1 is half plus 3 over 2n plus, okay, 3 over 2 plus 2 minus 1,000. Okay, we need to group like terms here. Let's start with the n squared. Okay, here is the n squared, and there's another n squared. So grouping this, what are we going to have? Half n squared plus half n squared. Half plus half is 1. So this will just give us n squared. Then now after this, we have to group the n's. This one plus this plus this. So we're going to say 3.2, which is 1.5, 3.2 plus another, okay, 3.2 plus 1 plus 3.2 plus 1 plus 3.2. This will give us 4n. This will give us 4n. So we've grouped the like terms. Now we can come up with constant 2 plus 2 plus 1.5. This is 0.5, which is half, plus 3.2 plus 2 minus 1,227. This will give us minus 1,221 equals to 0. We can either use factorization or quadratic formula. 1,221 divided by 1 divided by 16. I'm just trying to check the factors here. Okay. Okay, 3 by 87. So it means you have to use this. You can also use a quadratic formula, guys. So all I have, it's n and n, 37 and 33. Because 37 times 33, it's 122. 37 times 33, it's 1221. So then now, but I have plus and minus. So it means the n will be negative 37 or n it's 33. So we know we do not have a negative term, so it means this will be term number 33. But now, look, we want two consecutive. So it means it will be term number 33 and term number 34, because it's n plus, if you put 33 here, even there, this will be 34. But let's confirm this. What is term number 33 and what is term number 34, so that we can get the difference? It means where there is this equation, where there is n, we'll substitute by 33. So it will be T33, it will be half into 33 squared plus 3 over 2 into 33 plus 2. Then we do the same for 34. So it will be, let's say half is 0.5 into 33 squared plus 3 over 2 into 33 plus 2. This will give us 596. Then this time around, we put 34. 34, this will give us 631. Let's try to add this. 631 plus 596. This is 1,227. But the question wants to get the difference between these. So what will be the difference? The difference, it means we are getting term 34, we subtract term 33, which is 631 minus 596. So 631 minus 596 will give us 35. So when we add, it gives us 237, but when we subtract, it gives us 35. There are many ways to skin a cat. So we got the answer. Now let's return back to our question. Right, let me share again. So I want to address something very important here. Right, they told us that the sum of the two consecutive terms in this is given by this. Calculate the difference between the two. So we got the difference between the two. We know that is term 34 and term 33 and term 34. But sometimes, ladies and gentlemen, I want to tell you something very important. From the sequence of 4, what is the second one? 7, 11, 16, and 22. The first difference is 3, 4, 5, and 6. Then second, it's 1, and 1, and so on. Sometimes, guys, okay, this is the first diff. So if we do away with the first pattern from a quadratic, this one, whatever we're going to be left with, it will now become a linear pattern. So which means on a quadratic number pattern, the first different actual forms a linear pattern. Because sometimes they will say, for example, they will say, which term of the sequence in the first different will have a value of what? So it means now you have to use the linear pattern of, say, Tn equals to a plus n minus 1 times d. Then you know your first term will be 3, your common difference will be 1 on a quadratic. So it's very important to be able to know that. So which means now we went through algebra and number pattern. So then in the next session, I'm still gonna continue with, let's check, functions and graphs. So here we're given a hyperbola and a straight line. Then I believe the second one will be a parabola and exponential. So we'll talk about this in the next session. Then after that, we'll move on to the issue of financial mathematics. Then after financial mathematics, it will be a part for probability. Yes, it will be a part of probability where we look on tree diagrams, Venn diagrams if they're there, and also the contingency table. So I think I will stop here. Kindly don't forget to like, subscribe, and hit the bell notification button for future video updates. Thank you very much. Take care.